NASA has received a warning from Inuit and Native American elders that the world is undergoing a pole shift and their sky has changed. Elders have noticed that the sun has been rising in a different position and that their daylight hours for hunting have been prolonged. The weather has also become unpredictable. The Inuits have also reported that not only has the sun changed position but the moon and stars have too, and they all have an impact on temperature and wind, which makes weather prediction, essential to their livelihoods, more difficult. Is a reversal of the Earth's magnetic poles taking place? Volcanoes, earthquakes, strange noises from the sea. New shocking evidence points to a pole shift which, if it happens fast, will cause chaos around the world. It has been scientifically proven that the Earth undergoes a full geomagnetic reversal, or pole shift, around every 780,000 years. These reversals are usually slow, occurring gradually over long spans of time. However, at the start of the 20th century, that historical pattern appears to have been radically altered. A pole reversal, when the Earth's north and south magnetic poles start to swap places, reversing the world's magnetic polarity, has happened many times before. Scientists who track the history of the planet have identified 74 of these events by studying core samples. These are extracted from hundreds or thousands of feet down in the ground and in the thick polar ice. A sudden shift would throw the Earth's balance out so significantly it could trigger lethal earthquakes, tsunami on a scale we can hardly imagine, capable of washing right across the United States and every other major landmass. Volcanic eruptions so large and widespread that the resulting ash clouds and gases could blanket the sun's rays and trigger a new sudden ice age. Scientists look for evidence of previous Armageddon-style destruction by identifying chaotic sediments where narrow layers of earth, rock and ice record oddball events in the Earth's history in the form of bands of mud and tiny magnetically charged fragments. To scientists, these are clear indicators of sudden floods, ice melt or ash deposits. When this is found outside a long period of the cycle of freezing and melting in the Earth's history, it is an indicator of a pole shift. pole shifts cause a major increase in the movement of the tectonic plates. The giant lines of opposing cracks in the Earth's crust which push and grind against each other until they periodically release like a balled fist in a closed palm flicking upwards. There are now signs amongst the sharp increase in natural disasters and other strange, apparently unrelated incidents which point towards a possible reversal. It is widely recognized that magnetic north, that point at the top of the globe which compasses and devices which depend on magnetic navigation rely, is shifting increasingly quickly towards Russia from its current position above Greenland and nearer to Canada. It has moved 400 kilometers in the last decade and is accelerating. Our sun swaps its north and south pole every 11–13 years and has just done so. The effect on the sun is to stimulate the number and intensity of solar storms which can have a major effect on the Earth. They can interfere with TV transmissions and power supplies. Other signs which might indicate the effects of a magnetic reversal between magnetic north and south are an unprecedented 7 volcanoes which have started to erupt around the world in the last few days, and a major spike of 7.0 magnitude plus earthquakes, almost all of which I have witnessed personally a few days after the event as a documentary maker. The cycle started in Indonesia in 2004 and occurred again very recently in Nepal. These sharp increases in seismic activity do occur every 30 years or so and may be part of a natural ebb and flow, but they are another aspect of what could be a major trend in the light of the relentless and quickening march of magnetic northeast away from its original position. USGS and NASA are very concerned about a new magma chamber the University of Utah have discovered recently under Yellowstone National Park, in addition to the enormous lake of molten rock and iron they already knew about. This one is an astonishing 11 times the volume of the Grand Canyon. A sudden pole shift could become the push the magma chamber with the surface area of Los Angeles needs to blow up. If it does, most of North America would be destroyed instantly and a new ice age would begin. Another story which begs the question what on earth is going on is a 300-meter, 900 feet, high island which has appeared from the seabed just north of the tip of Japan in just one night. This area was the origin of the 8.9 magnitude earthquake which ripped through Japan in 2011, causing one of the worst tsunami of all time. Sections of crustal plates which suddenly move under enormous heat and pressure which cause earthquakes and tsunami have been known to move dramatically, although it is often never seen as it occurs miles down on the seabed. A new shelf 800 kilometers 500 miles, and 60 meter, 180 feet high, appeared off the west coast of Indonesia in 2004, which triggered the infamous tsunami wave which swept completely around the Earth's circumference 3 times. The new Japanese landmass appeared at almost exactly the same time as the Nepal 7.7 magnitude earthquake that took place 5,000 kilometers, 3,000 miles, away at the opposite end of the Eurasian tectonic plate. Finally, the weirdest account of nature what is a solar flare? A flare is defined as a sudden, rapid, and intense variation in brightness. A solar flare occurs when magnetic energy that has built up in the solar atmosphere is suddenly released. Radiation is emitted across virtually the entire electromagnetic spectrum, from radio waves at the long wavelength end, through optical emission to X-rays and gamma rays at the short wavelength end. The amount of energy released is the equivalent of millions of 100 megaton hydrogen bombs exploding at the same time. The first solar flare recorded in astronomical literature was on September 1, 1859. Two scientists, Richard C. Carrington and Richard Hodgson, were independently observing sunspots at the time, when they viewed a large flare in white light. As the magnetic energy is being released, particles, including electrons, protons, and heavy nuclei, are heated and accelerated in the solar atmosphere. The energy released during a flare is typically on the order of 1027 ergs per second. Large flares can emit up to 1032 ergs of energy. This energy is 10 million times greater than the energy released from a volcanic explosion. On the other hand, it is less than 1/10 of the total energy emitted by the Sun every second. There are typically 3 stages to a solar flare. First is the precursor stage, where the release of magnetic energy is triggered. Soft X-ray emission is detected in this stage. In the second or impulsive stage, protons and electrons are accelerated to energies exceeding 1 MeV. During the impulsive stage, radio waves, hard X-rays, and gamma rays are emitted. The gradual buildup and decay of soft X-rays can be detected in the third, decay stage. The duration of these stages can be as short as a few seconds or as long as an hour. Solar flares extend out to the layer of the Sun called the corona. The corona is the outermost atmosphere of the Sun, consisting of highly rarefied gas. This gas normally has a temperature of a few million degrees Kelvin. Inside a flare, the temperature typically reaches 10 or 20 million degrees Kelvin, and can be as high as 100 million degrees Kelvin. The corona is visible in soft X-rays, as in the above image. Notice that the corona is not uniformly bright, but is concentrated around the solar equator in loop-shaped features. These bright loops are located within and connect areas of strong magnetic field called active regions. Sunspots are located within these active regions. Solar flares occur in active regions. The frequency of flares coincides with the Sun's 11-year cycle. When the solar cycle is at a minimum, active regions are small and rare and few solar flares are detected. These increase in number as the Sun approaches the maximum part of its cycle. The Sun will reach its next maximum in the year 2011, give or take 1 year. A person cannot view a solar flare by simply staring at the Sun. Never look directly at the Sun. Eye damage can result. Flares are in fact difficult to see against the bright emission from the photosphere. Instead, specialized scientific instruments are used to detect the radiation signatures emitted during a flare. The radio and optical emissions from flares can be observed with telescopes on the Earth. Energetic emissions such as X-rays and gamma rays require telescopes located in space, since these emissions do not penetrate the Earth's atmosphere. Sometimes a sudden, rapid, and intense variation in brightness is seen on the Sun. That is a solar flare. A solar flare occurs when magnetic energy that has built up in the solar atmosphere is suddenly released. On the Sun's surface are huge magnetic loops called prominence. When they touch, they short-circuit each other, setting off explosions. The amount of energy released is the equivalent of millions of 100-megaton hydrogen bombs exploding at the same time. A solar flare contains high-energy photons and particles, and is released from the Sun in a relatively short amount of time. A few minutes. Even though the solar flare stays close to the Sun, relatively speaking, the material thrown into space by these explosions is radioactive. It is potentially dangerous to spacecraft and especially to people in space. Solar flares emit radiation across virtually the entire electromagnetic spectrum, from radio waves at the long wavelength end, through optical emission to X-rays and gamma rays at the short wavelength end. This radiation can corrode equipment, overload cameras or micas, and expose